Hi everyone, my name is Mr. Schuweiler, but most students call me Mr. Schu. And in this screencast, I'm going to share a little bit with you about what you can expect from this chemistry course. In terms of the content of chemistry, chemistry really focuses on two big questions. The first one is, what is everything made of? And that's really going to be the emphasis of the early part of the class, is looking into what is everything made of, the things around us. What is it that makes a rock, and a water, and a table, and why are those things different from each other on the level of particles and the smallest fundamental units? And then we're also going to look at why do things change. So why can water become water vapor, or something maybe that isn't water like hydrogen peroxide? Okay, and that's going to be really the focus of this class, and really that's what chemistry boils down to, is what is it that causes things to change. In this course, we have three goals. The first is to master chemistry to the level at which students will be expected to perform on the NC final exam. And yes, we do unfortunately have an NC final exam in this class. There's not much we can do about that. Second, to apply chemistry in meaningful ways through project-based learning. And third, to help students prepare for the demands and level of accountability that they will be expected to maintain in college. When it comes to students' grades, I firmly believe that a grade should indicate how much of the content a student has mastered. So if a student earns an 85% in the class, that should indicate that they understand 85% of the content. Not that they understood that 85% right away, or that they fell asleep in a class and that ended up in them losing some points, or that they were absent for a particular class period. Really, an 85% should say that a student understands 85% of the chemistry content. So to get to this point, the grade in this class is broken down into two components. Half of the grade is going to be composed of projects. And these projects are really going to be the big focus of the class. Really, the emphasis of everything that we do in class is going to center around these projects. There'll be one project per unit, and the class is broken down into, I believe, 6 units. Okay? So these projects are going to be group-oriented. They're going to require a lot of teamwork and collaboration. There's going to be one grade for the group, and there's going to be a heavy focus on applying the skills learned in the lessons. I'm also a firm believer in the idea that everything can be improved. Nothing is ever really good enough. The term good enough will not be used here. And so we use, the projects are going to have opportunities for improvement, for resubmission. Within 48 hours of the time that they're graded, students will be able to resubmit and to improve their products. The other half of students' grade is going to be tests, and these are there to hold us to a level of accountability, to make sure that each individual student understands everything and is not just banking on the team to kind of pull them through. There's also going to be a big focus with the tests on mastering the content and preparing for the NC final exam, as well as college tests. So these tests are going to be conducted using what's called standards-based grading. So standards-based grading is a little bit different from traditional grading in that it places a heavy focus on breaking down the content and making sure all of the learning objectives in the class are measured and measured evenly, that one concept is not weighed more heavily than the others, and that tests directly reflect these learning objectives and are direct assessments of what students know and can do. So, for example, in our very first lesson, lesson 1.1, which is thermal energy, that's the first lesson in Unit 1, there are 3 learning objectives for that lesson. You'll notice the 3 objectives listed over here, 1.1.1, 1.1.2, and 1.1.3. Okay? Now, each objective is broken down into 2 components, a key idea and a critical skill. The key idea is what students should have in their minds. Okay, and so these are the things that students should know and be able to understand. Okay, and so, for example, the very first key idea for the first objective is that temperature is a measure of the average kinetic energy of the particles in a substance. Temperature is measured in the Fahrenheit, Celsius, and Kelvin scales. And so these are things that students should know. But in terms of being able to actually apply that knowledge, that's going to be measured through the critical skills. So with this knowledge, students should be able to convert between the 3 temperature scales and relate the temperature of a substance to the average kinetic energy of the particles. This is something that is measurable, and that's something that students are going to be expected to do on the tests. So the key ideas are going to be a big component of the lessons, and critical skills will be a lot of what we do in class as well as through the projects. Also, this class is going to be flipped, which means screencasts like the one you're viewing now are going to be the primary mode of instruction. Now, I say primary in that it's not the only mode of instruction. We're not relying just on screencasts here, but they are going to be the big focus. And there's a lot of reasons why we do flipped instruction in this class. First of all, flipped instruction is based off of the concept that students, instead of doing homework at home, where they don't have the opportunity to ask questions of the teacher, and really that's where, during the practice and applying, that's where students need the most feedback and guidance. Instead of doing that stuff at home, they do that in class. And in class, instead of just listening to me lecture for 20 or 30 minutes, students are expected to watch a screencast in order to be prepared. Now, that doesn't mean that students have to understand everything from the screencast perfectly, although it would help. The screencast gives us a launching point, an opportunity to lay some foundations and some groundwork so that we can spend less time with me just talking at students where I can't really help them listen, and more time applying that knowledge and conducting investigations and labs and those things where I can help. One of the big reasons we do this too is not only because it gives us more time in class to do what matters, but also because a lot of colleges and universities are starting to investigate and play around with the flipped model. So learning from screencasts is a very different process. It requires a different skill set than learning from lecture. So it's good to practice that in a safe environment, which is why we're going to also be going over some skills for learning from screencasts like this. Also, there are going to be a lot of additional practice resources and support resources, and I'm available for students for tutorials whenever needed. So the students won't be left with the screencast and high and dry. Also, textbooks are available. I won't be issuing textbooks, but they will be available to borrow if you would like one. Canvas is going to be the central hub for everything that we do in this course. So when we look at the Canvas homepage for this class, everything is broken down into sections or categories. Okay, each unit will start with a unit overview. So for example, Unit 1, our very first unit, is Physical Properties of Matter. Okay, and there's going to be a unit overview where we'll talk about the project and sort of kick everything off for that unit and give us a mental organizer and ways of thinking about those things. Then, each unit is broken down into several lessons. This one's broken down into 5 lessons, each one numbered. And we saw the learning objectives for lesson 1.1 here, thermal energy above. And each lesson has its own objectives. Okay? And some lessons may take us 1 day to complete. Some lessons may take us 2 or 3 days to complete. Just depends on how complex the objectives are and what types of things we need to do in class to make sure we master those things. Each unit is also going to have a link to the project, which will explain all of the project requirements and expectations, what students will have to do, and all of that stuff. There will be practice and review available, some review questions and practice sources here. Those will also be listed in the lessons as well. And then lastly, the link to the test, which students will be taking in the class. So really everything that we do in year is on Canvas. Everything on this in this class is listed on Canvas, including the screencasts that students are expected to watch, any in-class assignments. All of those things are included in Canvas. So as part of project-based learning, since Discovery is a project-based learning school, this is going to be the primary emphasis and focus of the class, is focusing really on these projects. Okay? So all in-class lessons will provide mastery of key ideas that will be necessary to complete the project. The projects are also going to be standards aligned. So similar to the way that the tests will undergo standards-based grading, the projects themselves are going to be aligned to the standards. And so students will be expected to demonstrate mastery on Lesson 1 and Lesson 2 and Lesson 3 and all those objectives through their project. And lastly, projects can and should be resubmitted for up to full credit within 48 hours of being graded. Additionally, there are 2 honors projects that students will be completing independently. Okay, so these are not team-based projects like the other projects are. And these will be broken down into marking periods. So in the first marking period, students will be investigating jobs of the future, which is going to be a research essay emphasizing college-level literacy, research, and writing skills. Okay, so this is a big thing that students are expected to know and to be able to do at the college level, especially in college-level science courses, is to be able to research from reliable sources and summarize that information. In this particular research essay, students will be catching up with current trends and events in whatever field of scientific field that they feel like they would like to investigate. And then they're going to invent a job that does not yet exist, but they think there's really good evidence that this job could exist at some point in the future. The second marking period will be focusing more on experimental design. So students will be participating in some citizen science. And what that means is that students will be actually answering a question or making an observation somewhere in the community and designing an experiment to learn more about something or to solve a problem that they see. Okay, so a heavy emphasis on this will be on professional style lab reports, emphasizing experimental design and using evidence to form conclusions. Okay, so these are going to be really big skills that, again, students are expected to know how to do in college, especially the lab reports, which tend to not really get covered in a lot of other classes. So in terms of what students need for the class, some scientific or graphing calculator. We will be doing everything really on computers in this class, so students can use apps and all of that stuff for their calculators. However, when it comes to the final exam, they won't have those resources available. So if students have a scientific or graphing calculator that they can use over the course of the semester, that'll make things a lot easier when it comes time for the final exam. Second thing students need is something to write on and something to write with. We do a lot of work in class where sometimes students may need to write out some work, and sometimes it's easier to draw things. And we may even talk about some things that students want to take notes on from time to time. So this is a really good thing to bring. And the last thing is internet access. Since everything in this class is in Canvas and students are expected to watch screencasts outside of class, internet access is going to be a really helpful component. Now, if this is a problem, please contact me. But in addition, I do have, my doors are always open in the mornings and afternoons. As long as I'm here, students are able to come and sit in my room and to be able to work on these things. So, 10 keys for success in chemistry, and these are 10 things that students have told me in the past who have taken this class that really helped them. First thing is to do the lessons before class, so making sure that you come to class prepared and that you watch the screencasts. Secondly is to actively participate in class, because even though a lot of the work we do in class isn't directly graded, and a lot of the things that we do in class are team-oriented, that doesn't necessarily mean that slacking is going to result in success. Number 3, do all assignments even if they don't directly contribute to your grade. So I promise that I will never assign you something arbitrarily, that I'll never just create busy work for you, and that everything that I ask you to do will always be for a purpose. Okay, but what that means is that if I don't take practice as a grade, and I believe practice should be a safe thing, where you're not being graded necessarily on your first try, that does mean that you do bear the responsibility of taking advantage of those opportunities. Number 4, work with your partners on the project. So making sure that you are collaborating with each other, and what that means is that you are communicating with each other and really working together so that each member of the team owns 100% of the project, instead of just divvying up the components and you really own like a quarter of the project or a third of the project or whatever your part of the project was. Okay. Number 5, prepare for your tests. So make sure you study and do your practice tests and all that stuff. Number 6, each day builds on the previous one. And this is a really big thing, especially about this class. And the things that we study early in the semester will be necessary pretty much for the rest of the semester. Okay, so if you don't understand a lesson, it's important to go back and ask questions and understand that lesson right away, because it's going to be necessary for the next lesson. So if you don't understand lesson 1.1, you're not going to understand lesson 1.2, and you'll be completely lost in 1.3. So it's important to keep on pace. Number 7, going along with that, ask questions. Okay, I promise I won't ever get upset about anyone asking questions. There's no such thing as asking too many questions in this class. So please, please, please ask questions when you have them. Number 8, be careful in labs. So some of the labs that we do sometimes may be with some dangerous, slightly dangerous components. So it's always important to follow all lab safety procedures and guidelines so that we don't accidentally hurt anybody in the labs. Number 9, chemistry is not an easy thing to learn. So there's not, it really requires us to use observations that we can see to imagine a world that we can't see. And that's really kind of part of what makes chemistry difficult, is there are things that are so small that no microscope can really see them, and those are the things that we study in chemistry. And this can be hard to form mental images of, especially since those things don't always act like regular matter. Okay? And lastly is to take responsibility for yourself. Okay? Only you can earn the grade in this class, and only you can get the success that you want to find. If you have questions, if you have concerns, please feel free to contact me. My email address is david_schuweiler@nccs.k12.nc.us. Please feel free to contact me at any point during the semester, and I'm always here to answer questions for you.